The title of my presentation today is Potential Application of Terahertz Technology in Pollen Counting. My name is Wang Ying. I'm a PhD student from Spectroscopy Group. Today's presentation will be given as the following three main parts. The first part is pollinosis. In this part, I will introduce some background knowledge about pollinosis. For example, what is pollinosis and what's the mechanism behind pollinosis? After this part, I will introduce some methods that have been studied for pollen counting. And in the last part, I will introduce some ideas about potential usage of terahertz technology in pollen counting. To most of people, spring is a nice and amazing season that represents hope and vitality. But to some people, the world in their eyes is less beautiful and romantic as it should be, because they need to pack a lot of tissues for their runny nose and endure the itchy feelings of their watery eyes all the time. That's the typical symptom of pollinosis. Pollinosis is an allergic reaction to pollen grains that emitted from grasses, trees, and flowers. Usually, airborne pollen grains invade human body through airways, for example, nose, eyes, and mouth. On contact with mucosa of airways, the soluble allergen will be eluted from pollen and diffuse into mucous membrane to trigger the allergic reaction. Actually, the pollen itself is harmless to human health, but our immune system misjudges it as a threat and take a complex set of action to defend it. When pollen allergen enters the human body for the first time, it stimulates the human body to produce IgE antibody. IgE antibody will attach to the pollen allergen to neutralize it. The next time when same variety of pollen grains invade the human body, our immune system will produce a large amount of IgE antibodies. These IgE antibodies attached to the pollen allergen will circulate throughout the bloodstream to a certain type of cells that contain many chemicals that can cause inflammation. That's the mechanism behind pollinosis. Because pollinosis is difficult to completely cure, the pollen forecasting is very important for allergy patients. In Japan, more than 1/4 of the population is allergic to Japanese satin pollen. And in order to help allergy patients to develop more effective avoidance measures and promote better management of pollinosis symptoms, pollen report is usually given on the weather forecasting website based on daily pollen counts. Until now, the most widely used pollen counting method is based on morphological characteristics of pollen grains. Researchers need to distinguish target pollen species and count them under microscope. Pollen samplers are usually collected by durum sampler, on which a glass slide coated with adhesive Vaseline is fixed. Microscopic examination is performed after staining the pollen grains by some chemical dyes. This is a mainly used method, but the process strongly depends on the observer's subjective judgment, and the process is time-consuming and labor-intensive. A newly developed pollen counting method is called as halogen immunoassay, which is based on the specific binding between antigen and antibody. In this method, an adhesive tab is used to collect the sample pollens in the air. Then protein binding membrane will be laminated to the tab to conform a sandwich construction. Then add some elution buffer to the pollen to extract the pollen allergen. After extraction, the protein binding membrane will be blocked to prevent binding between antibodies and weakened protein binding sits on the membrane. Then first antibody will be used to recognize pollen allergen, and the second antibody with label will be used later to detect the first antibody. Then after adding some staining agent, hollow around the pollen can be seen for number counting. Although this method avoids the tedious pollen species discrimination work, but the counting process still needs to be conducted by under microscope. So I was wondering if we can establish a correlation model between pollen number and some indexes that are convenient to obtain. This is more efficient to monitor the pollen distribution in the air. So my research goal is to find a fast, simple method for pollen counting. Because terahertz wave corresponds to intermolecular vibration, so it has potential for detecting binding between pollen allergen and antibody. Moreover, terahertz wavelength is comparative to the pollen size, so pollen number change might be reflected by spectral variation. For example, the transmittance of metallic mesh is distinguished by its deep configuration, and the deep frequency is very sensitive to the refractive index on the refractive index of material on the metallic mesh surface. So in the ideal situation, before and after different quantity of pollen added to the metallic mesh, the corresponding deep frequency shift should be observed. Then based on the correlation model between pollen number and frequency shift, a fast, simple pollen counting process should be realized. So based on this hypothesis, I choose Japanese center pollen as my research object. Japanese center pollen is a major cause of pollinosis in Japan. As it shown in this picture, Japanese center pollen has almost a spherical appearance with a small tip, and its diameter is around 30 micrometer. And on the surface of Japanese center pollen, there are many small particles called ubish bodies, and the major allergen of Japanese center pollen is inside of these small particles. Because my research objective is to realize the pollen counting, and the detection process is based on the allergen and antibody interaction. So there are two basic questions that I need to make clear of. First is whether there is enough attachment strength between pollen grains and ubish bodies, and the other is whether there is enough binding strength between allergen and antibody. These two conditions directly decide whether the relatively huge pollen can be captured by the antibody. And the simplest way to make sure about that is to directly observe the possible phenomena under microscope. So firstly, I will fix antibody on some linker layer, and after some steps, add pollen solution on the linker layer and directly observe the phenomena under microscope. If the whole pollen can be successfully captured by the antibody, the future research work is possible. But before the observation, I need to find a way to fix the antibody on linker layer and to find a pollen solution that can realize allergen extraction without totally destroy the pollen grain. So the next step I will do is to make clear about antibody fix methods, get familiar with the device operation and chemical solution preparation. That's all for my today's presentation. Thank you very much for your listening.
Question? Go.
Your study is very interesting. And then after slide 9, to observe the pollen, you will use the scanning electron microscope. I think you don't need to use that because the pollen, the size of the pollen is very big material. So you can see just a microscope.
Oh.
I think to precise image to get you use a scanning microscope.
Thank you very much.
We have a digital microscope. Very easy to see.
Thank you very much.
Anyone else? The target is cedar.
Japanese is the pollen.
You have a pollen allergy?
No, I don't want to have.
That's good. I heard the cedar hormones comes usually February to March. Then after that, April, another pollen comes from the mountain. I don't know how big size, how big among kinds of pollen size is similar with that, 30 micrometer.
Yeah, pollen size varies from 10 micrometer to 100 micrometer.
Quite big, 100 micrometer, 0.1 millimeter. Maybe. Yeah, visible. So if it's visible, we don't need any detector. Any other question? I think yeah, your presentation material is easy to understand.
Thank you.
Okay. Okay, thank you very much.